In section 3.5, we will finish up this chapter on polynomials by discussing rational functions. Now, rational functions are different from polynomial functions, but they are the remaining function we haven't really spent a lot of time analyzing, so we're going to do it here at the end of this chapter. Remember, it was one of the parents that I asked you to be familiar with back in chapter 2, and the parent is f of x equals 1 over x. That would be the reciprocal function, which would be the parent for these. Now, we are only going to look at that particular one. We're not going to look at the one that is 1 over x squared, but we are going to discuss some features that go with this rational function. And one of the things we have to make sure we remember, because we're going to have a variable in the denominator, some function that has a variable in the denominator, make sure your denominator does not equal 0. That can't happen. And as long as we keep that in mind, then we will be able to recognize some things with these rational functions. Now, if you look at this reciprocal function, the parent for it, here are the things we discussed. We already have identified domain and range. We did that in chapter 2. Because if I ask you, is there any x value that has to be excluded, when I look at that denominator, it is x. Well, the only value I can't allow in the denominator is 0. So this is where we had a domain that went from negative infinity to 0. Now remember, I don't want to include 0, so I need a parentheses, union, and then I will have a second piece that goes from 0 to positive infinity. So we had to put the graph together in sections. If you look at this graph, here's what you see. We have a vertical asymptote at x equals 0. At that point, 0 can't be on the graph, and so it divides our graph into two sections. There's a section to the left of x equals 0, and there's a section to the right. Now, my range will be the y values that I get back, and if you recall, I told you the thing you have to ask is there any value that if I set the fraction equal to that I can't get back? Because remember, the y value is what you get back after you've plugged in something for x. So is there any y you can't get back? And if it's a fraction, the one value you won't get if you have a constant in your numerator, so if I have just a number, no variables up there, I can't get 0 for a y value, because the only way a fraction can equal 0 is if 0's in the numerator. And if there's no variable there, I can't turn it into 0. So my range will look just like my domain did. Now again, this is for the parent. We may see that we have some transformations in our equations, but what that means on my graph is if the y value can't equal 0, then my horizontal asymptote occurs at y equals 0. In other words, my x-axis and my y-axis will be asymptotes. They'll be the values that separate these pieces in my graph. Now, when I look at this, there are two separate sections, and they both are decreasing. As I move from left to right, I will see that it is decreasing on both pieces. So it decreases from negative infinity to 0, and also from 0 to positive infinity. When you're dealing with a rational function, you should find that they either both decrease or they both increase. It is discontinuous at x equals 0, because that's where that asymptote is. The graph doesn't exist there. And what I know is that the y-axis is a vertical asymptote, and the x-axis is a horizontal asymptote. If I were to ask you, do you recognize any type of symmetry? Hopefully you would see this isn't symmetry about the y-axis. If I fold, the halves don't match. So it's not an even function, but it is an odd function because I have symmetry about the origin. Now, as we look at a couple of examples on how to graph these rational functions, you're going to tell me the domain, you're going to tell me the range, you're going to tell me the intervals that are increasing or decreasing, and then give me the graph. So the domain and the range should be pretty simple. If I look at this denominator, it's just x. This is going to look just like what we did on the first page. My domain has to skip 0 because I can't let 0 be in the denominator. So I'm going to have those two pieces. My range also is going to have to skip 0. So I'm going to have asymptotes at the x-axis and the y-axis. So I'm going to put these dashed lines on both the x and the y-axis. Now, as far as increasing and decreasing, that's going to be much easier to answer after I graph. And in order to graph, I'm going to need to choose some values for x, plug it in, and then I'll be able to get my ordered pairs. What I do know is that I can't use 0. So let's see what happens if we use positive 1 for x. 4 over 1 is equal to 4. So that means I have a point at 1, 4. So when x is 1, y is 4. So that point is on my graph. Let's see what happens when x is 2. I would get 4 over 2, which is 2. So when x is 2, y is 2. So that point will be on my graph. I could use 3, but I can tell if I do that I get a fraction. So I think I'd rather use 4. And if I do that, 4 over 4 is 1. When x is 4, y is 1. And what I do know from comparing this to the parent is I know what happens as I move closer to each axis. This particular graph, as I move up, is going to get closer and closer to that y-axis, and then this end is going to get closer and closer to the x-axis. Now, I know there's another section of graph. These are going to be in opposite, kind of catty-corner quadrants. I need to see what happens on the other side of 0. Let's see what happens if x is negative 1. Well, 4 over negative 1 gives me negative 4. So I have negative 1, negative 4, which is this point right here. I'm going to have 4 over negative 2 when I plug in negative 2. So I get negative 2, negative 2. And if I use negative 4, I get negative 4, negative 1. And so I know this piece is getting closer to the x-axis as I go that way, and this piece is getting closer to the y-axis. And I apologize, my graph is pretty sloppy, partly because of this stylus. I'm having a difficult time getting right on the points, but hopefully you can see. Now, we do have one more thing to identify, whether the graph is increasing or decreasing. And if you pay attention, looking at these sections, hopefully you see both sections are decreasing. So it decreases from negative infinity to 0 and from 0 to positive infinity. Last example, we have f of x equals negative 1 over x minus 3. Now, same questions. Let's first identify our domain and our range. Remember, those help us recognize where our asymptotes are. So if I were to ask you, is there a value you exclude in the domain? When I look at this denominator, the one value I can't use for x is positive 3, because if I did use that, it would give me 0 in the denominator. So that tells me from negative infinity to positive 3 is one piece of my domain, and then from positive 3 to positive infinity would be the other. So what I have is an asymptote when x is positive 3. As far as the range, the one problem I've got for a y value is I can't get 0, and you should find that's going to be pretty universal in the examples you're going to see. So that means that my x-axis is a horizontal asymptote. Now I need to get some points on my graph, so I need to choose some things for x. I'm going to plug it in to the equation in order to find the y value, so I'll have an ordered pair. Since that asymptote occurs at positive 3, I want to move just to one side or the other. Let's see what happens when x is positive 2. And if I plug in positive 2 for x, I have negative 1 over 2 minus 3 is negative 1. Negative 1 divided by negative 1 is a positive 1. So I have 2, 1. So that means 2, 1 is right here. Now, notice that this is going to be the point that I need to figure out. Going up from there, I'm squeezing to this vertical asymptote. Going back to the left from there, I'm going to be squeezing closer to the horizontal asymptote, which is the x-axis. I can choose some other values, such as positive 1. What's going to happen when I do that is I'm going to get a fraction. I'm going to get negative 1 over negative 2. And I really don't think I need to put in any more values on this side, because I should see this is just going to squeeze this way, and this is going to squeeze up like that. What I do need to find out is what's happening to the right side of this asymptote. So let's see what happens if we use 4. And if I were to plug in 4 to the equation, I get negative 1 over 1. So that gives me the ordered pair 4, negative 1. So that's going to be this point. And again, if you wanted to try something like 5, when you plug in, you're going to get a negative 1/2. And what I know is this is going to squeeze up toward the x-axis. This part is going to squeeze toward this asymptote. And notice, because of the negative sign, this has been reflected over the x-axis. And instead of both sections decreasing, what we see is both sections now increase over the domain. From negative infinity to 3 it increases, and from 3 to positive infinity the graph increases. And that's all we're going to cover from Chapter 3.